Now for the second part of the Chapter 8, Section 2 notes on ellipses, we're going to work backwards if you are given some of the components, being able to write the equation. Here's the graph, which I know I showed you this image on the last section of notes as well, but I am adding some new comments that will be helpful for when we're working backwards. One helpful idea to note is that they're often going to give us a pair of coordinates, like they'll give us the two major axis endpoints, or they'll give us the minor axis endpoints, or they'll give us the coordinates for the two foci. Well, in every single one of those cases, the center of the graph will be the midpoint of those points they give you. No matter which pair of points they give you, the midpoint will be the center. So you can use the midpoint formula to find that coordinate, and then that means you'll know the h and the k values. Another important fact they often use is the major axis length, or they might give you the minor axis length. And that's basically defining how far apart the major axis endpoints are. Now, since that's all the way across the shape, that's like the diameter of it, you have to remember that we defined A as the radius from the center to the major axis endpoint. So it's helpful to know that if they give you the major axis endpoint, just cut it in half, that will be A. Or if they give you the minor axis length, that's the short diameter all the way across the shape. So cut it in half, and that will be the length B. So now here are some of the helpful hints and rules you'll want to use while you are writing the equation, given some information. The first fact I gave you is that when you were given a pair of points, and it doesn't matter what the pair of points are, they can be major axis endpoints, minor axis endpoints, or foci, you want to start by finding the center of the ellipse by using the midpoint formula. Now the midpoint formula is actually just the idea of averaging some numbers. Like if I say average your test scores, you would add up your individual test grades and divide by how many tests there are. Well, the midpoint formula is just saying if you have two ordered pairs, you can add up the x's and divide by how many there were, and then add up the y's and divide by how many there were. That will give you the point that is exactly halfway between the two ordered pairs. So start off by doing that, and then you'll have the center, which is the h and the k value for plugging into your equation. Next, when you have that pair of points, find the length from the center to either one of those same points that they gave you. So figure out how long that length is, and then you'll just need to identify if that length is A, B, or C. Now the variable you tie to that length will be based on the name of the specific points they gave you. So in the beginning, when you were finding the midpoint of the points, if it was the major axis endpoints, then the length from the center to those is A. If it was the minor axis endpoints they gave you in the beginning, then from the center to either one of those endpoints is B. And if it was the foci that they gave you, then find the center, and the distance from the center to that value is C. So make sure you are tying the terms, major axis endpoint with A, minor axis with B, and focus with C. Tying those terms with the variables will help you a lot. Next, we have to figure out whether A goes underneath the X value or the Y value. That's what will determine the difference between these two types of equations. So look at the name of the points they've given you. If you were given major axis endpoints, for example, then pay attention to whether it was the X coordinate or the Y coordinate that was changing for those endpoints. If X is changing, then you know to put A underneath the X variable. If Y was changing, then put A underneath the Y variable instead. If it was the minor axis endpoints, then remember that that's telling you what to tie B to. So if it's the minor axis endpoints, see if it's the X is changing or the Y is changing, and then put B under that same variable. And then here's the comment about the axis lengths. If you are given an axis length, then make sure you remember to divide it by 2. If it's a major axis length, divide it by 2 for A. If it's a minor axis length, divide it by 2 for B. So now here are a few examples to demonstrate this. The first thing I'm going to do here, since I was given a pair of points, I don't even care what the name of them is yet. I just want to find what would be halfway between them. So my center in this case, 0 plus 0, those are the two X values. And I'm going to cut it in half because I added two numbers together. That's the midpoint formula. Then for the Y's, I have a -3 plus a +3. And again, I'm averaging, so two numbers being added together, divide by 2. Well, 0 plus 0 divided by 2 is 0, and -3 plus 3 is 0, divided by 2 is still 0. So that's actually my center, which is my h and my k value. So now I know h and k, and I know the center of the ellipse. Well, from the center, I said to find the distance to either of the points they gave you from before. It doesn't matter which one you pick. Since it's the center, it should be an equal distance to either of them, so pick whichever one you prefer. I'm going to use 0, 0 to 0, 3. You'll notice that one of the variables never changes. So whichever variable doesn't change, you can actually just ignore that. They both have a 0 for the x coordinate. So basically, I'm just saying how far is 0 from 3? What is that length? Well, in this case, that's just a distance of 3. But to determine which variable equals 3, whether it's a, b, or c, that's where the name of the points matters. So we just found the distance from the center to one of the points, and since that point was a major axis endpoint, you have to remember that that is the a variable. And now I haven't used this other fact over here yet. They told me that the minor axis length is 4, but that's the diameter, and it's the short diameter since it's the minor axis. So I know to associate 2b with this number because I need to cut it in half, so that means b is 2. Now that we have a, b, h, and k, we're ready to write the equation. I always kind of like to start off just with the basic form of having an x minus something squared plus y minus something squared. And these equations are always set equal to 1 if you noticed on the previous slide for the standard form. So now I'm just going to plug in h is 0, k is 0, and then the a value, notice that for the major axis endpoints, the x-coordinate stayed the same for both of them, but the y-coordinate changed from -3 to 3. That's how I know to associate this a value with the y's. It was the y-coordinate changing for a. So now I know to put a with y, which means b goes with the other number. Now when this happens, when you have a plus or a minus 0, I actually don't really want you to write it that way. I'd rather have you clean it up and just simplify it to call this x squared, the minus 0 is not doing anything, over 4. And the same thing for the y's, y squared over 9 equals 1. So I was just trying to start off with an easy example that didn't have all of the h and k values in there, but make sure you don't actually leave things as x minus 0 or y minus 0 for your answers. Okay, here's another example. This one's going to be a little bit trickier because now I'm not centered at the origin. They gave me an ordered pair, so I'm going to start off by finding the center. So again, take the x's, add them up, and divide by 2 because that's how many numbers I added. Then take the y's, add them up. Now instead of writing plus and negative, I'm just going to write subtracting because it's the same thing. And divide by 2 because that's how many numbers I added. If I simplify this, 2 plus 8 is 10, divided by 2 is 5. -1 minus 1 more is -2, divided by 2 is -1. And that's the h and k value that I'll be plugging into the equation later. So this is the center of our ellipse right here. And then I can pick either of the points they gave me, it doesn't matter which one, the distance from the center to either one of those. So from 5, -1 to 8, -1. Again, in this case, the -1 for y is the same for both. So just ignore that for a second. The distance from 5 to 8 is 3. Now, based on the name of those endpoints, since those were the minor axis endpoints, the distance from the center to a minor axis endpoint is the variable b. And then they gave me the major axis length, but that's 2a, so just make sure you remember to cut it in half. So that means a is equal to 5. So now again, we have everything we need. We have a, b, h, and k. So I'm going to start off with kind of my basic outline of x minus something squared plus y minus something squared. And it's always equal to 1. So all I have to do here is start plugging in the h, k, a, and b numbers. Well, h always goes next to x, so x minus 5. K always goes next to y. If you subtract the -1, that becomes a +1. And to figure out which number, a or b, goes underneath the x's and the y's, It was the minor axis endpoints they gave me, and those are the b values. And for those ordered pairs, it was the x coordinate that was changing. So I just determined that b, for minor axis, goes with x. And since that number was 3, square it to get 9. That means the other number must go with y, square it, so the number is 25. One last example. This time they are only giving us endpoints. I don't have any axis lengths or anything. So starting off with the center, it doesn't matter which pair of points you pick. You're going to get the same center no matter what. So if you pick these, I will have 6 minus 6 over 2. And for the y coordinates, 0 plus 0 over 2. You'll probably get pretty good at identifying when the origin is the center, because you'll just start to notice that it's the same number with different signs on either side. So sure enough, 6 minus 6 is 0, divided by 2 is 0. So my h and my k values are 0 again. Now if I go from that center to the major axis endpoint, doesn't matter which one you pick, from 0, 0 to 6, 0, that would be a length of 6. And since they called that a major axis endpoint, from the center to a major axis endpoint is defined as A. Well, they also gave me the foci. There's no need to find the center again because the center is going to be the same one I already found. It's the center of everything. However, I can go from the distance of the center to one of those points, and that'll give me a new number and a new variable, because from the center to a focus is the length of 5, and that variable should be C, from the center to a focus. So 0, 0 to 5, 0 is the length of 5. Now the problem on this one is that I know A and C, but I don't know B. So this is one of those cases where you have to use the formula that A squared minus B squared is equal to C squared. So if they give you the foci or if they ask you to find the foci, usually you have to use that A squared minus B squared equals C squared formula that we talked about in the last notes. If you solve this equation, you could subtract 25 from both sides and add b squared to both sides. And then you could go on to take the square root of both sides and find that b is the square root of 11, but that's unnecessary, and that's just because the formula itself actually uses b squared. So there's no need to find b and then square it again afterwards. So I'm just going to start writing my equation, and actually since this one had the h and k's of zeros, this will just be an x squared and a y squared on the top. We don't have to do the minus h and minus k part. I know it's going to equal 1. So the trickiest part is always to figure out where do you put a, underneath x or underneath y. This time, my a value, the major axis endpoints, had the x coordinate changing. So since a is the major axis endpoint and x is changing for it, then a and 6 go together. Or a and x go together. And then that means the other number, 11, is b squared. So like I said, that's why there was no need to take the square root of it and then square it again to put it underneath y. So there we have our answer, and that's it for the notes on writing the equation given the components.